Good afternoon, ladies and gentlemen. Welcome our shareholders and guests. And I'm Russell Fitz, and with me is our CEO in the Gold Coast, John Mennega.
Hello.
In this webinar, we want to empathise the exciting developments ahead. We want to share our enthusiasm for the future and reassure you as shareholders that your investment and support is leading towards significant growth. Just to reinforce, all participants are unable to see anyone other than John and myself and what we may share on our screens, and no one can see you. Also, the team chat is automatically disengaged for participants for webinars. And we hope to provide you with a clear understanding of the current progress, updating upcoming milestones, and how it all ties into increased shareholder value. And this is an opportunity for us to give transparency in key areas: product development, manufacturing, collaborations, and market expansion, and above all, how the company is overcoming challenges and accelerating toward product demonstration and following on mass commercialisation. This webinar is about delivering a positive message, emphasising growth, opportunities, and the impact of our work. It's also a pitch for further investment necessary to achieve the opportunities and growth. And while we are in active discussion with potential investors and cornerstone partners, the importance of maintaining modest capital will ensure that we maintain momentum, execute on our manufacturing pilots, and advance key partnerships. Our webinar is divided into 3 sections. John's is focusing on explaining the broader vision and how Air Future is poised to meet the future needs of the energy storage industry. Russell focusing on tangible real-world applications where the product comes to life, showing how our technology is moving from concept to practical implementation. Questions can be asked during the meeting through your Q&A button on the bar, most probably at the bottom of your screen. Simply click it, write your questions and send. And you'll see that the questions can be made anonymously if you choose. And we will set aside time following our presentation to answer as many questions as possible. So we'll move straight into John's presentation, and I'll be sharing my screen and then pass over to John.
Hi, everybody.
Hold on, John. I'll just do your...
Sorting out the technology here.
You've got a fair bit of echo now.
Yeah, it was that difficult.
Set up the screen here.
Echo's still there?
Yes, it is.
What about if I turn the volume down a bit?
I just got to... Yeah, that might work. At the moment, I've got all your slides up on one screen, which we do not want.
Sorry, everybody. We'll be with you in a moment. I can start to talk anyway, Russell, while you're sorting that out.
We're on slide 1. All good?
We all good?
Yep.
Everybody's experienced along development gestation process with NBI, but I want to point out to you that the development has actually followed a very logical path and explain a little bit to you why. Can you go back a slide, Russell? And explain to you why it's taken so long, back to the orange side. Why it's taken so long, why we're now, thank you, why we're now ready, and further field development. Some of you might recognise this slide as being the front page of the website. And if you look up the top there, you'll see documents. Fourth from the right. Now, if you go to that over the course of the next week, you'll find copies of all what we're talking about, including the slides, the flyer, and the main document. And those documents differ to the others because they're focused on commercialisation. Now, when we say on the website we're a universal alternative to batteries, we're not kidding. Batteries have a number of issues, including cost, safety, they degrade and they're not clean. But the primary issue about batteries that a lot of people don't realise is that they're shorter duration and they don't have high capacity, which means that if you spend $100 million on a 100 megawatt battery, it's probably got about 4 hours of scope or its catchment area. So why do it? Because what the batteries do is they stabilise the energy grid. And it needs stabilisation when you get a whole load of renewable energy coming onto the grid. So you'll see that the feed-in tariffs are no longer as exciting as they used to be because there's now too much renewable energy for the grid. And therefore, what we need storage, critically need storage for renewable energy, and we need it to be long duration, not only to cope with the huge increase in renewable energy, but also to do something about these perennial blackouts. Okay, Russell, next slide. Next slide, you've gone too far. Back one.
Oh, sorry.
That's it. That's it. Now, this is a really interesting slide. On the right-hand side, you'll see a cavern large and you'll see fixed large storage, the last two pictures on the right-hand side. Now, they are compressed air. And hundreds of millions of dollars is going into compressed air storage. And the one second from the right is a company called HydroStore. And within Australia, they have been engaged to provide energy storage for Broken Hill, where we had a disaster with regards to blackout not too long ago because transmission lines were down and so forth. So what you have with compressed air storage on this large end on the right-hand side is you have long duration energy storage, which is needed to shore up the grid. Now, if you go to the left of that and you look at the small, medium and large storage, that's us. So what we are saying is that we can create exactly the same effect on the right-hand side by aggregating customers. And we can aggregate customers through small individual or large storage using things like microgrids, etc. So Russell, next slide. You'll notice that these are 1B, 2B, etc. because these are the same slides that we're using for investors and partners and so forth. They're exactly the same slides to give the background. And the 1A refers to notes about this slide, but we don't have time for that in this webinar, but if you go to that document section sometime over the next week, we will be adding that. Now, this first slide starts with MDI, and it's basically about the science and the MDI laboratories. And MDI did something wonderful. They captured compressed air, they related it to automated intelligence, thermodynamics, mechanics, and they were able to create something with compressed air that had never been done before. And compressed air had been around for a very long time, but not the way that MDI does it. And they did this via their laboratories in France. And it took a long time, and they worked along with Tata and others, etc., and so forth. And you can see the engine laboratories on the left all the different engines they were able to create, and the storage lab on the right-hand side. And that was the beginning of MDI, where they laid the platform for the next stage, and the next stage was product. Next slide, please, Russell. And here MDI was able to evolve the technology that they had developed with the modularity, in other words, how you can make it bigger or smaller and still do exactly the same thing for the customers and the users. And also they created something which is totally unique to the energy industry. Within the one system, and a battery is an example of a system, they were able to separate out the capacity and the size to the actual storage and the energy generation. For any technical people within the audience, that's the difference between kilowatts and kilowatt hours. In other words, how much energy you store versus how you deliver that energy are completely able to be separated. And that has enormous impact for being able to address all the different areas within the grid. And they're able to control all of that through the air valve system of the energy tanks. Now, bearing in mind that those tanks can be put underground a little bit like in the old fossil fuel service days, or current days still, the ecology of the system and the attractiveness of the system, let alone the scale of the system, is something that we really refer to as next generation. And on the right-hand side of this picture, you see the United Nations award that they gave MDI in New York for their potential to contribute to the future. And on the left-hand side, you see the AirPod vehicle, and on the right-hand side, you see the energy storage unit. And that was the second stage of the operation, moving from science to product. And now we move to the third stage. Russell, next slide, please. It's one thing to develop the science and to capture the science and to make that your platform technology. It's another thing to then produce products. It's another thing again to then deliver products for customers. And this was the next stage of MDI. Now, bearing in mind, while this is taking place, the years are ticking over because this takes a long, long time to do. But the middle company there, which is Veolia, the huge European waste company that's all around the world, became a customer of theirs for that particular unit that you can see on the screen, which is still on the streets. What stage is it at? It now needs larger engines. And this is a step that we will be doing in early stages of the commercialisation. On the right-hand side, you see what became the very famous World Expo air train, which is the MDI train that was produced and commissioned by the World Expo to run their people around the Dubai World Expo. And on the left-hand side is a complete contrast. We show how the AirPod is able to be adapted for commercial applications. Now, at this point, MDI was traveling quite well, and they had reached the point where it was ready for mass commercialization, but things fell apart. And the cause of things falling apart was COVID. And COVID hit France very badly. And World Expo finished up delaying for 12 months when MDI had already committed resources and people and office space and manufacturing and everything to the project. And because the Expo could claim that it was no fault of theirs, but it was what they call force majeure, in other words, acts of nature, there was little compensation. And MDI came to, firstly, a very difficult financial position, and secondly, a realization. And that realization that the future was not about individual customers. The future was about mass commercialization. And mass commercialization requires a totally different model and a totally different skill set and a totally different team and a totally different country. And in our work with MDI, what we convinced MDI, and it wasn't too difficult, was to say that Australasia was potentially the world leading geography to be able to develop the mass commercialization for MDI in conjunction with ourselves. Because it also became obvious that MDI didn't really have the skill sets for mass commercialization, nor were they in the right place. So the partnership between technology and commercialization, in other words, MDI and Air Future, is a little bit of a partnership made in heaven. But having said that, there is still the exercise to now bring it together with the aftermath of COVID and flu and goodness knows whatever the south of France has experienced. So moving on, Russell, to the next slide. What MDI and Air Future in collaboration are now saying and now realising is that with the problems that are being experienced with batteries and energy storage and the shortcomings in electric vehicles, that the market is enormous. And it ranges from things like the left-hand side of this particular picture 4B of the green air, which is an example of a small compressed air product, to what we call the module air, which is a larger product that again you can see on the website, that was developed in the aftermath of the air train as a larger commercial vehicle. To the right-hand side where you've got the small, medium, large, whatever you require, storage that can be added to all different elements of the grid, including homes, rooftop solar, communities, industry, microgrids, virtual power plants. From an energy and electricity point of view, where is this heading? The problem that you've got historically with centralized grids is that they're becoming inefficient, they're becoming expensive, and they're becoming ecologically unpalatable. In other words, via transmission and so forth. The new development that's taking place is decentralization, where consumers become prosumers. In other words, they produce electricity as well as consume electricity. Now, this has an enormous advantage. And one of those advantages is that you can apply more renewable energy because you're doing it at location. A second one is that you've now got resilience, that you're able to protect blackouts. Where I live in Queensland in Australia, we've just had Cyclone Alfred. And we had hundreds of thousands of blackouts The other day, I forget where it was, I think it might have been in Peru. They had storms and so forth, and they had millions of blackouts. Well, why have you got blackouts? Well, you've got blackouts because you can no longer transmit the power to the end user because that power is coming from a centralized location. So if decentralization energy makes so much sense, what's the major reason that's holding it up? The major reason that's holding it up is batteries. Because batteries do not have the scale and the duration to be suitable for end location storage. And that's why the amount of rooftop solar is way, way in excess of the amount of battery storage. And that's why they're pumping hundreds of $millions into compressed air energy storage, such as HydroStore, which is taking place at centralized locations via taverns, etc., etc. Now, the key word I just mentioned there is taking place at centralized locations. In other words, good as compressed air energy storage is at centralization, it still has to go via transmission and it's still not locational. We are locational. So we can basically go to locations, including remote parts of Australasia and the world that are very, very hard to service, including microgrids that are desperate for energy storage, and including home solar, which is finding batteries too expensive. Once we combine compressed air energy storage with heat storage by capturing the heat of our compressed air energy system, then basically we will have the holy grail of energy technology. We will have, well, energy storage technology, sorry. We will be capturing and using compressed air and heat energy within the same system, which makes the system both very affordable, very efficient, and via the heat and the cooling that comes out of the tail end, we're able to provide those two additional facilities at location. So HydroStore and other large compressed air energy storage, what are they doing about the heat? Exactly what I just said. They are already doing this. So this is perfectly technologically understandable, and it's the next step that we will add to our development once we move to the field. Next slide, please, Russell. The last quite earth-shattering capability that we have is that we have decentralized manufacturing. In other words, we manufacture in regions. Quite likely where you are as the audience, we would be able to come and manufacture. Why can we manufacture regionally? Because of the nature of our technology, but also because we have the flexibility to be able to outsource, and Russell will talk more about that, versus creating factories. We are completely flexible and completely modular. And you will see the factory on the left-hand side that created the airplanes, the factory in the middle that created the development, and the objectives that we have for Australasia on the right-hand side to create factories to be able to produce our product within the country. And many of you will know that this is exactly what the USA and Donald Trump is trying to achieve, more manufacturing. And he's not the only one, because I know for a fact that Australia is very, very keen to create more localised manufacturing, and we have the capability to do it, and we have the capability to do it yesterday. Russell, next slide. So as the final slide, we take you forward to the next stage. In this picture on the right-hand side, which is now quite old, we had already started the negotiations and so forth with MDI, with Cyril Nager on the right, that tall fellow on the left being John Mennega, and that other handsome fellow second from the right being Russell Fitz. We already started those negotiations quite some time ago. But we are low on resources. We have Russell, we have John, and we have Cyril, but with the restructuring of MDI, we are now rebuilding that pack. But what we're doing in moving forward to commercialisation is we are focused on the specific 4 projects that Russell will talk about, being the technology transfer, being the local manufacture, being the energy storage, and being the transport pilot. Now, my closing comment is that I come from the investment banking industry and I understand finance and investment, and we've been delayed till this point in seeking cornerstone and climate and innovation investment from a large perspective, but we're not delayed anymore. And this is the exercise that we're undergoing right now, which we can talk about subsequently in a further seminar or do a newsletter, because I'm going to hand over to Russell now to take the running with the commercialisation stages for Australasia. Russell, over to you.
Thank you, John. Now I'll just go through the separation here of screen sharing and then going back in. Right. I'm looking at another screen on the table in front of me, which shows me the gallery view or the audience view. So, thank you, John, for that excellent presentation and explanations. Now, first slide for me is ticking boxes. And what attracts investors? Well, more importantly, we know what puts them off. And over the years, we've received feedback pointing out areas for improvement, and we've worked hard to address those. And our focus has been on advancing Air Future to a point where we can now present ourselves credibly to cornerstone investors. So we now tick a lot of boxes. The key challenge in front of us still is lack of revenue, but we're extremely close to overcoming that hurdle and being able to demonstrate future revenue flows. And a major milestone is the MDI technology transfer, which we are undergoing at the moment, which, along with the ability to manufacture and demonstrate a product, represents a game-changing opportunity for us. The transition project. And this project introduces the MDI know-how and intellectual property to Air Future, which opens the door to significant operational advantages. And currently, we're focused on component identification and pricing relating to those very significant IP of MDI, the electro-pneumatic valves and heads. And this is a big project for Shamrock, our precision engineers, to fit in with their existing work schedules. However, it's likely to be completed prior to Easter. Progressing to consider and develop robust manufacturing and assembly processes for scaling production is a focus. And expanding our relationship with MDI, allowing us more independence and new expertise, comes from this project. And the ability to plan for manufacture of multiple products in one facility comes from this project. And the current focus is completing the costing and pricing for the key components, such as the electro-pneumatic valves and, of course, the bottom engines. Manufacturing pilot consists of two projects. There's the energy and the transport. There are two engines selected by MDI. The smaller one is a two-cylinder 10.4 kilowatt diesel engine. It's a Yanmar product. And then there's the three-cylinder 0.9 litre 109 horsepower Renault engine and the Smart 4.2 Brabus, which the engine we're familiar with because it was used as the bottom engine in the Expo Explorer. And the Yanmar engine will be used in the Green Air Golf and the AirPod, and also for smaller scale electricity generation and storage. And the area where that will be used is around the 7 kilowatts, so we're looking at domestic. But one of the advantages against batteries of the MDI technology is that it can be boosted. So the normal revs for their engines is about 1,500 revs per minute, but by increasing the revs to 2,500 to 3,000 revs, you can boost the output of the generators. So you've got 7 to 12 kilowatts being the range for the Yanmar engine. And then with the Smart 4.2 engine, which you're again familiar with, it's the Dubai Explorer and will be used in the Modulaire orders. And in the energy and energy storage projects, it's a 21 kilowatt alternator generator, which can be boosted, and this is significant, to 42 kilowatts and even up to 52 kilowatts. Now the range for, if you are having to deliver 52 kilowatts from batteries, you could be spending $70,000. We can do that, or intend to be doing that, with one engine. So the integration of the head and valves to the bottom engine is a significant part of the project, and there's been adequate information on our website to show pictures of MDI doing those very tasks on their website for preparation for the Dubai Expo. And the engine will also feature the unique capability to both compress and expand air for energy generation, and essentially running two operations simultaneously. And the electronic valve control is unique. So a distinct advantage to have the bottom engines, so the already component operating engine, saves considerable manufacturing costs. And the sourcing of the three-cylinder engines has been, of course, discussed with Cyril, and we've identified two sources for those. And for the Yanmar engines, they can be sourced locally. Our energy pilot demonstrates the practical, real-world application of our technology, showing its potential across a variety of industries. The core technology, sorry about that. One core technology can provide multiple benefits, including electricity generation, energy storage, heat and cold integration, and the ability to use biofuels like methane, enhancing sustainability. We've chosen a path that offers the greatest advantage and is cost-effective to implement, which is the dairy industry. Dairy industry requires electricity for hot water, for refrigeration, and for running their plants, and for irrigation. They produce biofuels via effluent. Farmers create a network management headache for lines companies by multiple farmers turning on their plants at the same time. And not to mention quality of the electricity dropping below acceptable levels, causing potential damage for farmers to electrical plant is a significant concern for farmers. The farmers require energy storage to overcome these issues. Pardon me. The MDI Air Lab above has already proven our technology's success in controlled environments, and we see huge potential market, particularly within the dairy industry. And we're working with one of our shareholders on our project. And this is an example of the value of our shareholders to contribute to our market implementation. And we're building cooperation within the industry, government, universities, and that is all work in progress. And with a long product life and low operating costs, this technology can also offer massive savings for customers in these sectors. And that is the focus of our energy pilot. Transport. Transport's focusing on the off-road vehicles. And much of the integration work is being completed by MDI's partner, Air Mobility in Sardinia. And the focus has been in integrating the Tata Nano engine into the Green Air. And that's the advance from then moving on to the engine for us. And they're also preparing the moulds, which the fiberglass moulds for licensees, and that's no mean effort because there's a lot of work goes into that. And the MDI to complete the design of the electromatic head for the Yanmar engine we'll use in our transport applications. And you'll see on the left-hand picture, there's the smaller engine with the electro-pneumatic valves fitted, which enables compression and expansion to take place with one engine. And we are seeing good progress with air mobility, but with an additional funding for us, we could advance that even further. Heat expansion and energy loss recovery. Now, the implications of our energy project is that we'll be able to demonstrate a game changer with global implications. Firstly, capturing compression heat and expansion cold and converting it to usable energy provides real advantage for compressed air usage. Of course, prior to this, that has been wastage. And that has worked against the operational acceptance of compressed air as a source of providing solutions. So looking at the process of heating and cooling as a system, as against the single use, is essential to our commercialisation. And additionally, the implications of expanding compressed air prior to the engine through a simpler inline burner placed between the storage tank and the engine can increase the air volume and efficiencies towards 70%. And shareholders will be familiar about us talking about that when we look at the mileage predictions for the AirPod of 110 kilometres on air and up to 320 when we use heat. But within the dairy industry, for example, or for any industries where you've got a biofuel, it is hugely significant. And the financial advantages are demonstrated in the attached cost-benefit table, and the price advantages speak for themselves. And again, this is most probably the first time we've presented financials, or at least we've presented financials for a long, long time. So what I've done is to try, rather than saying how much is a product going to cost, what is our market window for our product as against existing technologies? Now, it's clear that when we're looking at in the litres of storage or the larger energy required with kilowatts, when we're looking at parties requiring more than 30 kilowatts to 75, which would fill in a lot of farms, we have to provide storage. So our storage is compressed air bottles. And the equivalent for that is batteries which provide storage. But batteries in themselves also provide the electricity. So we still need to manufacture and supply a manufactured product, which is our engine. And so what is the window for us within that engine? Now, you'll see on these calculations that if we're taking the extreme of a farm wanting 75 kilowatts and they're wanting that delivered for 2 hours, then the window there is an $80,000 window to be producing something that is competitive to existing batteries. And that is by using the heat from heating between the compressed air and the engine, which reduces the amount of storage required, and that is the advantage. But of course, what I haven't factored in is the cost of providing the methane to be going through the little burner. But what we haven't also built in is the advantage of being able to use the waste heat and the cooling to save significant electricity costs. So I think this is a very reasonable way to start to explore some of the dynamics around the energy that we can produce and the value that we can start to add. But it's going to be, I'll be meeting with parties at the University of Canterbury towards the end of the week, and I'm going to be discussing that and looking at how we can best start to expand these operational advantages into mathematical calculations to present to investors. So, takeaways and the final call. The message is simple. We require support for our opportunity. And we have a disruptive technology with multiple significant advantages: technical, manufacturing, and ecological advantages. And we've established a clear path to commercialisation, and our products can be replicated globally, expanding the potential for growth in international markets. The partnership with MDI strengthens our position and will allow us to help advance the technology on a global scale. For investment, the path ahead is a game-changing opportunity for investors, and it's a timely opportunity. For once we've achieved key funding milestones, the opportunity for new investors to join at this valuation will be limited. And we're seeking investment for working capital at the same time as project funding, which will drive the next phase of our growth. And it's a chance to get involved before the company accelerates, securing your stake in a growing future-proof business. Thank you. So we can now move on to any questions, and I just have to, I can say I've got one question, which was from several questions from one shareholder which were presented. And he asks, can you give us an update on progress with the Shamrock engineering? Is the technology transfer complete and have they started building engines yet? As I said, that's work in progress. Do we have any large investors who have actually put money in yet or are very close to doing so? No, we're working with investors and we're now ready to be presenting them with the ingredients we have, but that's very much our focus, and that's starting this week. And we've done a lot of work on preparing documentation, and there will be another larger substantial information memorandums which we'll be able to present to the larger, more substantial investors. Did Air Future have a presence at the recent government investment conference? And if not, why not? No, we didn't. We weren't on their radar, and that's something that we will be looking to become, have a higher presence in the next months ahead with the government. Thank you. I have some questions here which I'll just read through. What has changed in the last 12 months? Any sales, any publicity or pilots? I think we've demonstrated that there's a lot has changed. The environment's changed. That's the wider global environment. Certainly, the ability for us to demonstrate the products is very evident. What pressure is the compressed air stored at for the examples on page 5? MDIs in the carbon fibre tanks, they've used 248 bar, but the energy required, the compressed air pressure can be a lot less. They've used 248 bar because that's puts a lot of energy in a very small space. One of the advantages of the reversible engine and the electro-pneumatic head is that can compress to very high pressures using a 4-stage compression process. But certainly there are significant efficiency advantages by lowering the pressure. Is there a demonstration project to showcase the integration of this technology for energy storage at a home level with solar power integration? First will be, as we're saying, in the where we're going to get the most results to demonstrate the wider implications of the MDI technology, and that's the anywhere between what the engine we have is anything above 20 kilowatts. So initially, no, but certainly the smaller engine is right behind that because we see a considerable market for the domestic storage market. Certainly, again, if you've got surplus heat, that's where and can start to use that to expand the air. That certainly makes it extremely handy. It looks like at the beginning that there were some audio difficulties, and my apologies to the shareholders who have had some issues there. And I hope that hasn't been widespread, and if it has been, my apologies, and we'll look into the reason why. And John, have you anything you'd like to add in regard to our presentation?
Yeah. Now I just got it. The other one. Sorry.
Oh, you want to go back to your presentation?
Sorry, I'm just trying to get rid of that echo. Can you hear me okay?
Yes, there is a little bit of echo there.
Yeah. The shareholder asked a question about attending the investor conference. There are a lot of investor conferences and so forth, and I come from that background, so I understand it very well. But a lot of them are not a lot of value because what we're talking about here is very specific. And if you look at some of the specific characteristics, you're talking about innovation, you're talking about climate, you're talking about manufacturing, energy and transport and so forth. So you can attend these conferences, but a better way to do it, in my opinion, is to do the research. So if you take any particular couple of organisations, right, let's say for argument's sake the Australia Renewable Energy Association, that invests billions of dollars. The key is to understand exactly how they function. Or if you want to take, say, energy companies like AGL or Origin Energy, to find out how they might partnership and what it is they need and they invest in and their associated investment organisations. Or if you take manufacturing, if you take, say, for argument's sake, in Australia, the South Australian government, the funds have got up for manufacturing, etc. And so it goes on. We've done all that homework. We can provide lists incredibly long and incredibly detailed and so forth, what we've been holding off till this point, where when we get the investor on board, we can create and achieve jointly a milestone. And that milestone might be the first engine, it might be the first energy demonstration, it might be a green air pilot, it might be formally securing the intellectual property, etc. But it's a milestone. By achieving a milestone, what we're able to do is to then formally create shareholder value. Now, bearing in mind that we're a private company, there are two things that we need to be able to do. One is to add shareholder value for a private company. The second is to create liquidity. When we bring external investors on board, both of those two desires are going to be more straightforward. And certainly from an investor point of view, they're going to be wanting to immediately add value. And we've been holding back on that quite conservatively as an audited company. But when we open the floodgates to that, the potential for increase in valuation, as you would know from other technology companies, is, in my view, enormous. Russell?
Thanks, John. Just again, going back to that question, there were two conferences. One was the Investee conference last week, but prior to that, there was the announcements for assisted immigration, where investors can get advanced residencies for investing into New Zealand companies above 5 million. That process is being managed by New Zealand Trade and Enterprise, and I have approached them, and we are providing information about our company through that process. So we'll see how that unfolds. There's no further questions has come through, and we're slightly over our time, but I'd like to thank you, shareholders, for your time today. And the past year has been a year of significant progress for Air Future. From transferring the MDI technology to advancing our pilot projects and testing our technology in real-world settings. We've turned challenges into opportunities and are now in a stronger position than ever. We've built a solid foundation and are excited about the road ahead. Continued support and collaboration are key as we reach our new milestones. Your belief in our vision has been instrumental to our progress, and as we grow, your continued involvement will be crucial to our success. Thank you again for your trust and support, and we're excited about our future and glad to have you along for our journey. Thank you. Enjoy the rest of your days.